So unit 5 of software modeling and design is the design pattern. Okay, so what are design patterns exactly? Let's start with the definition of design patterns initially. So what are design patterns exactly? Design patterns are nothing but they provide a pattern to design your own software, that is known as the design pattern. So first of all, you will see the definition of design pattern. This is the agenda that we are going to cover in today's lecture of 40 minutes. First of all, we are going to see what exactly design patterns are. Then, what is the need of design patterns and why do we use design patterns? Then, the benefits of using design patterns. Then what are the different types of design patterns? There are three different types of design patterns, which is creational, behavioral, and structural. So there are even multiple types for each of these different design patterns, which is creational, behavioral, and structural. So we are going to see all these design patterns in detail in the upcoming slides. Okay, so which textbook to refer to learn the concepts of design patterns is, the name of the book is Design Patterns, as you all can see here. Elements of reusable object-oriented software, and this book is written by the Gang of Four. These four authors are known as the Gang of Four. Okay, so the four authors are Eric Gamma, Richard Helm, Ralph Johnson, and John Wilsades. So you can refer this book. In detailed description about all the design patterns is very nicely explained in this book. Okay, now let's switch to what are design patterns. Okay, so what are the design patterns? Design pattern is nothing but it is a general reusable solution to commonly occurring problems within a given context. Now, what is a reusable solution for a code? Let's take an example of an architect. Now, everyone knows what architect is doing. Architect actually designs a layout of the building he is going to build, right? In the similar manner, design pattern provides us to design a layout for a software that we are going to build. Okay, so architect usually designs a building, designs a layout for the building. Like if suppose we want to build a building which contains all the flats of 1 BHK. Now what is a general layout of that 1 BHK? So a general layout of 1 BHK contains one hall, it contains one kitchen, it contains one bedroom. So this is a general layout. If we want, we can have a gallery for that particular house. Okay, so this is a common layout that every architect will use to design or to build a house, a 1 BHK house. Now, even if the architect is different, he is not going to change the layout of that 1 BHK flat, right? So this is what a pattern is. Now, this is a pattern for that particular architect. Okay, so architect is having his own pattern to build the buildings. Same in the similar manner, we are having the design patterns to build a solution for the problem defined in our software engineering. Okay, so we all know that we are developing the software just to find out the solution for some kind of problem statement that we are getting. So design pattern provides a template to find out the solution for the problem that we are dealing with. Okay, design pattern, it does not provide a solution actually. It just gives us a template. It just gives us a direction to find out the solution. Okay, now common reuse is at code level. And one more thing, design patterns can be used for multiple number of times. Once we design a pattern for any code or for any software, that pattern is completely reusable. Now suppose again, seeing the example of that same architect, layout of 1 BHK flat is ready. If he wants to build 100 1 BHK flats, then he's not going to change the layout for every 100 flat, right? He is having a same layout to build that 1 BHK flat in every scheme or in every building. In the similar manner, we can reuse the pattern that we have designed for multiple number of times. These design patterns are language independent. Okay, we can implement these design patterns in Java, we can implement in C, in C++, in any language that we want. These just provide a template to find out the solution of the problem defined in software engineering. Again, I am repeating, it does not provide a solution for that particular problem. Okay, so common reuse of the design pattern is basically at the code level. In our software engineering, some kind of example of design patterns are the standard libraries that we use, like math.h, stdio.h, and the GUIs in Java. You all know the use of stdio.h. You all know the use of math.h. It contains multiple functions that we directly use. So every time we are importing this library into our code, we don't want to implement its functionality, right? It is already implemented, and that's why we are using it. So this is the benefit of design pattern, that we can minimize the developing time of the software development by using these inbuilt design patterns. So these are the examples of design pattern. Even user defined libraries such as bank.h, library.h can also be used. Okay, so these design patterns are language independent, and these design patterns, they just provide a template and they don't provide a solution to the problem statement. Now, what is the need of design pattern? Okay, so why do we need a design pattern? So design pattern is used to address some of the common problems that we come across when we are coding or developing a software. So how to properly create a class is a main problem whenever we are developing any software. How to properly create a class is a main problem. So the structure of the class, to define a structure of the class, we have a new design pattern with us. We can directly import that design pattern and we can directly use it. Will solve our problem, or at least it will provide us a direction to solve that particular problem. Then next is how to instantiate an object. Object instantiation. Object is an instance of a class. So when we initiate an object, for how many times we should initiate that object, then for how many times we should create that particular object, use it and destroy it. These are the many multiple problems, common problems that every developer comes across. So these design patterns provides a solution, or they provide a direction to solve these type of problems. Now these all problems will be handled when we will see the different types of design patterns in the upcoming slides. Now, how to interact between the objects. We are creating object in different multiple classes, so how to interact between those objects. So this will be again addressed. And how to write the reusable code. Design patterns basically provide the reusable code which we can reuse many multiple number of times, million number of times. There is no language barrier, there is no platform barrier, there is no number of barrier that how many times we can use this design pattern in our code. Industry peoples, they are continuously using the design patterns because it saves the time. If we know that someone has already worked on that particular problem and someone has found out the solution to that particular problem, then we are supposed to work on some another problem. We will get some more time to work on other problem than working on the same problem, right? So this is what we are going to do using the design pattern. What are the benefits of design pattern? Benefits of design patterns are, it provides a robust code. Then it provides the code reusability. We can reuse the code for multiple number of time. Then they are highly maintainable. Okay, maintainability they provides us because we can edit the pattern. It is not the case that this is the same code, this is the same pattern, these are the same functions that we are using. It just provides a layout. It does not provide a detailed code. In various number of applications we can use the same pattern but with the different codes, so they are maintainable. Then they reduce the total cost of ownership. Now, how do they reduce the cost of ownership? They reduce the cost as well as they reduce the time, because they save our time in developing the same thing for multiple number of times. Then we can use them in loosely coupled applications. Mostly it is an advice to use them in loosely coupled applications, because when any applications are tightly coupled, at that time tightly coupled application doesn't allow us to edit the code of that application very easily. as they are tightly coupled and they are very complicated to edit. So in loosely coupled application, there is flexibility provided for the developers to edit that code easily. And that's why it is recommended that we should use the loosely coupled applications. We should use design patterns in the loosely coupled applications. Okay, now the main point, these are the major contents of our unit 5. So what are the types of design patterns? There are three major different types of design patterns. First is creational design pattern, second is behavioral design pattern, and the third one is structural design pattern. So we are going to see one by one. There are multiple different types under each of this type. Okay, so there is a very big hierarchy. Total in software engineering, there are 23 design patterns, from which in our syllabus we have 6 design patterns that we are going to study in detail. And whatever 6 design patterns are included in our syllabus, they are the major design patterns that are used by all the industry persons in their recent developments, in recent real-time applications. Okay, so first we are going to see creational design pattern. So what is a creational design pattern? The name itself suggests. Creational design pattern, it deals with creation of the objects inside a class for that particular software development. Now, for every application that we are developing, we develop that application with the object oriented approach. Okay, so the basic thing to use this design pattern is we have to use object oriented approach to design that particular application. So using the object oriented approach, obviously we are going to design multiple classes. We are going to use multiple object oriented concepts to design those classes. Then we are going to instantiate multiple objects to access the functions from those classes. There might be a structure defined for the classes. The classes consist of various member functions as well as variables of different data types that are defined inside a class. So creational design pattern basically deals with creation of objects in that particular class. Okay, that's why that design pattern is known as the creational design pattern. There are multiple different types of creational design pattern: a singleton pattern, factory method design pattern. We are all are going to see the different types of design patterns. Okay, so next type of pattern is the behavioral design pattern. So what is a behavioral design pattern? Behavioral design pattern basically deals with the behavior of a class. Now, how can we exactly define the behavior of a class? Class consists of different data types of variables and member functions. When different objects communicate between different classes by using different object oriented methodologies, then it is known as the behavior of that particular application or that particular classes. Okay, so design pattern deals with the behavior of that particular class, how different objects interact with each other, what type of data they pass using the multiple member functions. Okay, all these things are defined under the behavioral design pattern. Then the third type of design pattern is the structural design pattern. Again, the name itself suggests structural design pattern deals with the structure of how to define a class in a particular code. Now we have a structure for the class, member functions, and the variables. So how to define a structure of a class? Again, there are different types of structural design patterns that we are going to see in the upcoming slides. So these are the major types of design patterns that we are going to see. Now initially we will start with the creational design pattern. Okay, so creational design pattern, these are different types of the creational design pattern. Now different types of creational design pattern is Singleton design pattern, factory design pattern, builder design pattern, and prototype design pattern. So these are the 4 different types of creational design pattern, in which singleton design pattern and factory design pattern are included in our syllabus, and builder design pattern and the prototype design pattern, these are not there in our syllabus, but we can study it as a part of reference, as a part of content beyond syllabus. Okay, in the book that I showed you in the previous slide, design pattern. Let me show it once again, as I think multiple participants have joined just now. So this is the textbook that you have to refer. Name of the textbook is Design Pattern by Gang of Four. Four authors: Eric Gamma, Ricard Helm, Ralph Johnson, and John Wilseds. Okay, so these are the four authors which designed this book. This book contains every detailed concept of all the design patterns that we are discussing here. Okay, and including this, I'm going to share my notes. I have already shared multiple PPTs and multiple things on the Moodle with you. Okay, so we will start back to the creational design pattern. So these are the four different types. Singleton design pattern and factory design pattern are there in our syllabus. Initially, we will start with the singleton design pattern. Now, singleton, the word itself specifies the meaning of that particular design pattern. Single means one. Okay, so single means one, and as it is a creational design pattern, it provides us a specific pattern to create or instantiate an object. Singleton specifies one, so only once we can create an instance of a class. What it means: a class of which only single instance can exist is known as a singleton design pattern. Okay, now you will say, why there is a need to create only single instance of a class, right? As we can create multiple instances, as we can use those multiple instances simultaneously for multiple applications. But we are going to see applications of the singleton design pattern. There are some requirements in the software development when there is a need to design a singleton design pattern. Then there is a need to develop only one instance of an object. Okay, so there is a need, and that's why we are going to create only one single instance of a class. Now in code, when we are going to define a class, public class, we have defined it, then we can create the object of that class. Now as we can see, every developer can create multiple instances of a class. In this singleton design pattern, we are going to see how to restrict that developer from creating multiple instances of a class. So for that purpose, singleton design pattern is provided. This pattern is known to be the most simplest pattern in all the types of design patterns. Okay, it is most simplest pattern in all design patterns. Again, I am repeating the definition for you all. A class of which only single instance can exist is known as the singleton design pattern. Now, there is a method to define or to write the design pattern. I am explaining the method to write the singleton design pattern. In exam also, whenever any question is asked to you, or even in your real life also, whenever you are going to use any design pattern, please follow the same method to implement the design pattern. First, we are going to define the intent of the design pattern. Intent means what is the purpose that we are going to design that particular pattern. Then what is the motivation? What motivated us to write that particular design pattern? Then what is the structure of that design pattern? Structure defines the layout of that particular design pattern. Now the structure or the layout can be designed or defined in the form of class diagram, or it can be defined in the form of object diagram when there is the need for object instantiation or communication between those objects. And implementation can be defined in the form of code. You can write the code for any of the examples that we are seeing. Please mug up all the 4 points, and you have to use this pattern. You have to write any of the design pattern using this method only. Okay, first we will define the intent, then we will define the motivation, then we will define the structure, and then we will define the implementation of the design pattern. Now we will see the intent of singleton design pattern. As intent of singleton design pattern is, class can have only one instance and it provides a global point of access to it. Why there is a need to have only one instance of a class? Because we want to create only one instance or take only one image of that class, and user should be able to communicate with one global image of the class. Okay, then what is the motivation? Singleton work by having special method to get instance of the desired object. Okay, desired object, we can get an instance of the desired object. We can have a global point of access to it. Then as you all can see, structure of the singleton design pattern is mentioned here. Now please look at the screen very carefully. This structure is defined. I hope all of you are able to see this class. One singleton class is defined here. Okay, this is a class diagram, UML class diagram. One singleton class is defined here. As we all know the structure of a class, the first row, it defines the name of the class. Second row, it defines the variables of the class, and the third row, it defines the member functions of the class. Okay, in the member function we have defined one constructor with the name of the same class, and there is one function with the get instance. Okay, now this get instance returns the object of the class singleton itself. Why there is a self loop for that particular class? Because it returns only one object of that class itself, and this is how we are restricting to create only one instance of the object. Okay, we will see the code, then the concept of the singleton design pattern will be clear to you. We will directly move on to the implementation. Later on, again we will see the structure of the design pattern for more understanding. Now look at this example. Please look at the screen carefully. As you all can see the code, this code is written in Java basically. Okay, you can write the design pattern. You can design your design pattern by using any platform. You can write it in C++, you can write it in Java, anything. Okay, so I have written it in Java. Now public class singleton. First step is to define a class with the name of singleton. As singleton is not a keyword, let me make this thing very clear to you. Singleton is not a keyword. We are defining our own class with the name of singleton. You can give any name to your class. This class is the main class which contains the main function, and this class will be a public class. That's why we have defined public class singleton. Then this class contains public static void main function which passes an argument with the form of string. Okay, now switch on to the next class. This line we will see afterwards. Switch on to the next class. Now we have defined one more class here, which is ABC, a sample class we have taken. Under that class, there is an object of the class itself. We have created an object of the class itself. So the first step to define a singleton design pattern is define static. The object is defined as static, and static ABC object is equals to new ABC. We have created only one object which is defined as static, and this is the first step of defining a singleton design pattern. Then next step is to define the constructor. See here, we have defined the constructor of the same class ABC, and please make that constructor as private. Now why we have made this constructor as private? If we will keep this constructor as public, then in the singleton class we can create any number of objects for that particular class ABC, and for that number of times that constructor will be automatically initialized, and we don't want that. In the singleton design pattern, we have to restrict the user for the creation of only one single instance of the object of a class. So again I'm repeating, we have a class ABC here, a sample class ABC. Initially we have created object of that class ABC. Name of the object is obj. Then we have defined static to that particular object. Second step is that we have defined the constructor of the same class, and that constructor is private. Okay, so now this constructor will be accessed by same class only. This constructor cannot be accessed by the class singleton, as we have defined it privately. Then we are going to define a method inside the class ABC. That method is the get instance method. Again, this get instance is not a keyword. It is not a standardized method name. You can give any method name as you want. Okay, this is just a sample code. I'm showing it to you for understanding of the singleton design pattern. We are defining a method for the class ABC, okay, which is static. The method is public, as it will be accessed by the class singleton also, and this method is static. And what this method will do? This method will return the object of the class ABC. I hope this is clear with you. This method will return the object of the class ABC, which is created here. Okay, now see the singleton class. In the singleton class, we have a main function. Inside the main function, we are going to define object of the class ABC. Okay, now what this object will do, object 1 is equal to new ABC. We can write or we can initiate the object in the same way. ABC object 1 is equals to, instead of this we can write new ABC. But what will happen if we will write this new ABC, any number of instances will be created if we will write this. We want only one instance, and that's why we have defined this method, which is get instance for the class ABC. And that's why instead of writing this new ABC to instantiate the object, we are using ABC dot get instance. And what is the implementation of get instance? It will return only one instance of the object, and here your constructor will be initialized automatically, and your constructor is a private constructor. I hope you have understood the singleton design pattern. So singleton design pattern is basically used to create only one instance of an object for the class. The steps are: initially define the class, okay? Inside a class, create an object of the class, make that object as static, then define the constructor of the class, make that constructor as private so that no other class can access that particular constructor, then define a method using name with the name of get instance or any other name in the same class, and return the object of that particular class in that method, but return only one object. Okay, and then call that get instance method in the class singleton, which is the design pattern class. So we are calling this get instance in only once, and that's why only one instance of the object will be created. Now what will happen if we will create one more object? Suppose class ABC. I cannot write here with this pen, but consider ABC space obj2. I am trying to create one more object in the same class. What will happen? ABC obj2 is equals to abc dot get instance. Again we are calling the same method which we have defined in the class ABC. So what will this do? Again it will create only one single instance which will be same as of the object 1. So there is no point in defining obj2. So this is what your singleton design pattern is. Again we will move on to the structure here. Look at the structure once again for your understanding. In the singleton design pattern, there is only one class defined as the singleton. Instance of the class is variable is singleton. Then get instance is only one method which returns only one object of the singleton, and we define the constructor for the singleton design pattern. Okay, I hope this design pattern is clear to you. This is the simplest design pattern in all the 23 types of design patterns. So this was the singleton design pattern. Don't worry, I'm going to share this PPT, this slide with you all, and also I'm going to share this video with you all if anyone missed the lecture. So now we will see the applications of the singleton design pattern. Now what are the applications? You must be thinking that where we can use this singleton design pattern. So we can use this design pattern in configuration classes. What are configuration classes? Each one of us is using mobile phones as well as laptops, right? So in the mobile phones, there is the setting option, as you all can see. Setting option, वो setting हम change कैसे करते हैं? How we are doing that setting option? We just click onto the setting option. We change that setting one time, right? We cannot change the setting, means we cannot create multiple instances for the class setting. Consider in your mobile phone there is a class defined for those settings. Okay, and there are multiple functions like display functions. You can change your display settings from the display functions, and there are system settings. You can change the system settings by using the class system. So these configuration settings we can change it for once. It saves the image for once, and it implements that image every time we switch on or off our phone, or whenever our phone is on or in a working mode. We cannot create multiple instances. What will happen? just consider what will happen if we will create multiple instances of setting. किसी एक ने एक टाइप का सेटिंग कर दिया, किसी दूसरे ने दूसरे टाइप का सेटिंग कर दिया, फोन कंफ्यूज हो जाएगा कि हम किस टाइप की सेटिंग यूज करें, राइट? There should be only one instance of that setting in the mobile phone. So in configuration classes, this singleton design pattern is used. Then next is accessing resources in the shared mode. Now shared mode, you all know we are accessing Google Drive. Google Drive is a best example where we can save the documents and we are using it in a shared mode. So if someone changes any document in the Google Drive, it is that change is reflected to all the participants with whom that document was shared. And if anyone removes that particular document, then this change is reflected with all the participants with whom that document was shared. So here we are having a single instance of that shared file. We are dealing with a single instance of that particular document or that particular application. So here we are using the singleton design pattern. Then website designing, shopping cart, you are logging in, right? You are logging in, and in the website designing, when you are shopping, you are storing some items into the shopping cart. Now, if someone changes your shopping cart through the same login, there should be only one instance of the shopping cart, right? You cannot have multiple instances of the shopping cart. How are you going to place your order if you are having multiple instances of the shopping cart with the same login? That's why singleton design pattern is used, which should create only one instance of that particular class in the website designing. These are some global examples where the singleton design pattern is used in website designing, in accessing resources in a shared mode, and in configuration classes. There are many more such real-time examples where I can show you that singleton design pattern is being used recently. And basically, it is a good practice to use design pattern. Actually, it is not compulsory for every developer to use the design pattern, but it is suggested by some of the good developers to use design pattern as it saves time. Just think, someone has already worked on the same problem that you are coming with, and you are again working on the same problem to find out the solution. What's the point in wasting time? Instead of, use the solution or the template given by some other person and utilize your time in developing or discovering something else, right? So this was about the singleton design pattern. Okay, I hope the concept of singleton design pattern is clear to you all. If you have any queries regarding any type of design pattern, you can ping me anytime in my personal window or WhatsApp, or you can mail me, or you can post your queries on Moodle. I will open a discussion forum regarding this topic on Moodle. Okay, you all know my website as I have shared with you. Now, next type of creational design pattern is the factory design pattern. Till now, we were seeing the singleton design pattern. There are two types of creational design patterns that are included in our syllabus. Next is the factory design pattern. Now, what is a factory design pattern? This is also known as factory method design pattern. Factory and factory method design patterns are the same thing. In some books, the name is written as factory method, while in some books, the name is written as factory design pattern. So what is factory design pattern? It differs the instantiation to subclasses that you can have polymorphism on creational methods. Okay, regarding singleton design pattern was using encapsulation. How it was using encapsulation? As we were hiding the instantiation of the object, we were hiding the implementation of the method get instance was creating only one single instance of the object, which was the restriction for us, which was the restriction given to us for the development of that particular software. So it was implementing the object oriented concept of encapsulation. Now factory design pattern is implementing the concept of polymorphism. Okay, so polymorphism, you all know, in polymorphism what we are doing in the polymorphism, um, we are creating a main class, and then we are creating multiple subclasses from the main class. all the subclasses inherits the properties of the main class. Main class is also known as the parent class, while subclasses are also known as the child classes, which inherits their properties. Now, what is factory design pattern? Factory design pattern deals with again creation of the objects, but it deals with the subclasses. Like the main subclasses can inherit the instantiations made in the parent classes. Are you getting this? Child classes can utilize the instantiations created in the main classes. This is known as the factory design pattern. Okay, so what is the intent for the factory design pattern? Please remember the method to define or to elaborate any type of design pattern. First, we are writing its intent, then we are writing its motivation, then we are writing its structure, and then we are writing its implementation. Writing implementation with example with one code is compulsory. Okay, and also designing a structure is also compulsory. Based on the structure, we can write any code for any application or for any example. You can just take one sample example as we just saw in the singleton design pattern. So what is the intent of the factory design pattern? To create the objects without exposing the creation logic to the clients. Okay. Once we will see the structure, you will understand the complete layout of this factory design pattern. Motivation is newly created objects can be referred by the client using common interface. Let's move on to the structure directly to understand this factory design pattern more clearly. Please observe the structure carefully on your screen. Okay, observe the structure. Now in the structure, don't get confused as there are multiple classes defined. Okay, I'm going to explain the class one by one. Now please see the class that I'm going to show you. First, there is a class shape. One shape class is defined. Okay, sorry. This one shape interface is defined. You all know for what purpose they define the interface. This interface has one method which is draw. Okay, this interface has one method which is draw. It returns nothing. Only method is defined here. All the subclasses circle, square, and rectangle will implement the method defined inside the interface. Okay, so what we have done till now, initially we have defined one interface with the name shape. Shape is an interface which has one method which is draw. Now the circle, square, and rectangle, these are the concrete classes which implements the method in the interface shape. Okay, so circle is a method which will implement the method draw in its own way. So the method will be overridden here. Are you getting this? Same method which is defined in the interface shape will be overridden here, and its implementation will be written for the circle. Same method inside the class square, again its implementation will be written but for the class square. Again same method in the class rectangle, which implementation will be written for the class rectangle. Now this structure, till now this structure is clear to you. Now next, we will define one more class with the name shape factory. Okay, one more class with the name shape factory. Now this shape factory will have one method which is get shape, which will return the object of the interface shape. It will return the object of type shape. Okay, so this is one more class, that is shape factory, and this is one more class which is factory pattern demo. Factory pattern demo actually contains the main class. Now client will be accessing with the factory pattern demo. Client will be accessing the shape factory. Client will not be accessing this complete structure where we have implemented our interface. That interface, again methods of the interface are implemented by the three different concrete classes. So client, now this client will not access this part. Okay, client will not access this part, interface and its implementing classes. Client will access, or client will ask the method to implement to the class shape factory. This shape factory will communicate with this interface and the concrete classes to implement the method of draw. Now if client passes the word as circle. If client passes the shape as circle, then shape factory will create the object of this class circle, and it will implement the function of draw. Are you getting this? If client passes the shape square, then client will ask the shape factory class to implement the method of draw by passing the shape as square. Then this shape factory will create an object of the class square, and it will implement the method draw for the shape square. Again, same thing will be repeated by the rectangle. This factory design pattern will be more clear to you when we will see the uh, code for the factory design pattern. Okay, so let's see the code for the factory design pattern. For your reference, we have the structure at the top right corner of your screen. If you require, please refer to the structure. Okay, what is the first step for factory design pattern? First step for factory design pattern is create an interface first of all. Okay, so create an interface. Shape interface यहाँ पे जो दिखाया है वो हमने सबसे पहले create किया है. What is there are simple steps in Java to create the interface public interface shape, and it has the definition of the method draw. See, in interface there are no implementation of any method. All the concrete classes will implement this method. Okay, so we have created the shape till now interface. What is the next step? Next step is create the concrete classes implementing the same interface. Now these are the concrete classes. We have three concrete classes, that is circle, square, as well as a rectangle. These are the three concrete classes that we are going to create. Now see the code for these three concrete classes. I hope it is visible to all of you. Please look at the code carefully. It will help you to understand the factory design pattern carefully. We have created a simple class, a rectangle, which is public. What we want is this class rectangle implements the interface shape. Okay, as look at the structure again, rectangle implements the interface shape, so it should implement the interface shape, and we are overriding the method of draw. See here, we are overriding the method of draw. And what is the implementation of this? We are inside the rectangle, we are, this is a sample code, so we are just displaying a message that we are inside a rectangle and we are inside the draw method. So this is the implementation for rectangle. In the similar way, we are implementing the class square again, which is public, and it implements the shape. Then again, same method draw is overridden here with the message. And again, we are creating another class which is circle, which implements the interface shape. And again, we are overriding the same method draw by representing the same message. Have you understood till now? This box that you can see here, we have written code for this structure till now. Are you getting? Now we will implement these two classes. Step 3 is create a factory to generate the object of the concrete class based on the given information. See here the structure again. This is the shape factory that we are going to create right now. Now what this shape factory will do, create a class shape factory which is public again. Now there is a method shape, there is a method get shape defined under the class shape factory. Okay, now what this will do, this will pass a string. Now this string can be the type of your shape. It can be a circle, it can be a rectangle, or it can be a square, as we are having three different concrete classes here. Okay, so if we are passing the circle, simply if shape type equals circle, then what we have to do, we have to create an object of the class circle. Look at the structure once again. We are implementing this shape factory class. Okay, under the shape factory class, we are having one get shape method. This get shape method will create the object of the concrete classes, which will implement the overridden method draw that implements the interface shape. Are you getting this? So if shape type equals circle, शेप टाइप को क्लाइंट ने अगर सर्कल दिया है, तो सर्कल शुड क्रिएट द ऑब्जेक्ट ऑफ दिस क्लास सर्कल. इस सर्कल का ऑब्जेक्ट क्रिएट करना चाहिए उसने, एंड इस सर्कल का ऑब्जेक्ट क्रिएट करके ये जो ड्रॉ मेथड है, ये ड्रॉ मेथड को इम्प्लीमेंट करना चाहिए, राइट? सो व्हाट वी आर रिटर्निंग हियर, दिस मेथड रिटर्न्स द ऑब्जेक्ट, okay, of class circle. Similarly, if the shape type equals rectangle, then this again method returns the object of rectangle. If the string is square, then this returns the object of square. Otherwise, if your string is null, if you are passing nothing, it should return null. Or if any other string other than circle, rectangle or square is there, then you should return null. Are you getting this till now? We have implemented this from this class. Now only one final class is remaining, which is step 4. Now create the factory class. Okay, now create a factory pattern demo class. Now what this factory pattern demo class will do, this class which will be there for the client, this class contains the main function. Okay, client cannot communicate with this structure. One more thing I'm repeating again here, client cannot interact with this structure. Client can interact with only one class, which is this. It will create the object of these three classes and it will implement the overridden these method. So client can directly access this, and this is the motto of factory design pattern, that we are hiding the implementation of these classes here. This is the motivation and this is the intent of the factory design pattern. Now in the main class, what is there in the main class? Again, shape1 is equal to shape factory. We are creating the object of the class shape factory and we are passing the string from the client. As this is the class for the client, we are passing the string for circle and it will implement the method of shape1 dot draw. It will implement, it will call the method draw, and then we will get the output that it will implement the draw method from the circle. So now what will be the output? Output will be that we are inside the circle. Same is with the rectangle and same is with the square. So in the factory pattern demo, we are simply creating the object of this class and we are accessing the method draw through this shape factory class. This is what your factory design pattern is. Are you getting this? Let's see the output of this. So output is, initially we have called the draw method for the class circle, then we have called the draw method for the class rectangle, and then we have called the draw method for the square. So this is what factory design pattern is, which hides the implementation of this interface and the concrete classes. If you want to change the code, there is no need to change this structure. You can directly change the code of this shape factory only, and you can implement the same thing more and more again for more and more applications. Okay, so I think our time is over now. That's all for today, and we will again carry on with the next design patterns, which is the structural and behavioral design patterns in the next session and their respective types. So thank you all of you for listening the lecture, and happy learning. Stay home, stay safe. Bye bye. I request you all to please leave the meeting so that you can join other session, next lecture, so that you can join Pooja ma'am's lecture.